All right, so I want to do 1.22b, which is just show that this y equals x squared over 3 plus c over x satisfies the equation xy prime plus y equals x squared. First, what order differential equation is that?
First.
First or second?
First.
What's causing you to say second? Because that's a good.
The two exponent on the exponent, I'm thinking that's probably wrong.
Yeah. So I would say that x squared, right, is a second order polynomial, right? But order is the wrong word for polynomials. It's a second. What's the right word for polynomial? Degree is the right word for polynomial. So it's second degree, right, as a polynomial. As a differential equation, we're thinking about it as a polynomial in terms of derivatives, right? So what's the highest order derivative I end up taking? First. So one way you could check that is if I had a solution, right? Like, say this one. What am I going to do to try to shove this in there? Like, what's your first step going to be? Yeah, you're going to take some derivatives. How many of those do you have to take to try a solution?
Just one.
Just one in this case, so it's first order. Cool? All right, so I should figure out what y prime is. So what's y prime?
2/3 x.
Okay, 2x over 3
And c over x squared. Or minus c over x squared.
minus c over x squared. Okay, cool. Now what do you do with that? Plug it in, right? So you got x times that. So you got 2x over 3 minus c over x squared e plus what? X squared over 3 plus c over x equals x squared. What have I done that's wonky?
You didn't solve for x?
No.
You could distribute your x. I don't know.
Yeah, I should do that. So not what do I need to do, but what have I done that's a little wonky here?
Parentheses.
Like this? That would make you feel better?
Yeah.
Okay. I did something wonkier than that.
Oh, wait.
I'm assuming that this is equal right now, right?
Yeah, you should put a
Yeah.
question mark over
I
it,
should
equals,
kind of-
and see
yeah.
if that's true.
You guys with me on that? Like, I don't know this is actually equal. It might not actually be a solution. Like, there might be another typo, right? Apparently the probability of that is 1 at this point. So let's multiply this out and see if we get x squared, right? So over here I got 2x squared over 3 minus c
over x. So x just cancels.
Do some x's cancel maybe?
Yeah.
Okay. And then I got plus x squared over 3 plus c over x. And that's supposed to be equal maybe to x squared, right? Okay. And and it is. Because c over x is cancel, and then you got 2/3 of an x squared and 1/3 of an x squared. So all told you have
X squared.
3/3 of an x squared, which is a full x squared. Check. Cool. Good?
Yeah.
Okay, question. When is this true?
X is not true.
Yeah. You guys see that? So this is a solution. So if I had to say this absolutely with nice precision, I would say y equals x squared over 3 plus c over x solves xy prime plus y equals x squared on minus infinity up to 0 and 0 up to infinity. You guys with me on that? Why am I saying on this? Yeah, because y doesn't even make sense when x is 0, right? So the differential equation doesn't make any sense there either. You guys see that? True or false?
Then I have another question actually while I'm thinking
About this?
Well, it was related, it was earlier when I couldn't tell the, the order. If it was like y double prime times y single prime, would that still be a second order?
Like this?
Yeah, because there was, in an earlier problem, it says find the order of the equation. There was one where the two multiplied together.
Yeah, there's 1A.
Yeah.
I thought it'd be fourth at first place.
Yeah.
So that would be second order then?
This is second order differential equation.
Okay.
Yep. That is super weird.
Yeah.
And it's even worse, right, when they have it written the way they do.
Yeah, with Leibniz, it looks like you're taking
Yeah.
a derivative of
So-
it.
If they have it in kind of prime notation, like it sort of vaguely makes sense. But if that kind of thing is written in Leibniz notation,
I hate that.
Yeah, that's how it was.
so the key, the like clue that something funky is going on here is what?
It's a,
The 2 before the 1.
it's not an of, it's a times.
It's this, the fact that there's two y's, right? Because we taught you guys to kind of treat these like fractions,
Oh, yeah.
right? Like I told you, even in Calc 3, right? I was like, yeah, just treat them like fractions, it's fine. Right? You do like, okay, so if I wanted to do the third derivative of y dx, right? Another way I could write that is I could write d dx of the second derivative of y, right? And these two things look awfully frickin' similar, right? It's just that this guy, this first d dx, that's the idea of taking a derivative of whatever you're multiplying it by. And this guy is actually a derivative that's already been taken, right? That's the derivative of y. You guys with me on that? That's a really subtle point. I won't be writing differential equations today. I would never write this in a differential equation. I would always write y prime times y double prime. And honestly, I would probably rearrange set equations so that that didn't appear in it. Cool?